Sorry, guys, waiting for it to load. Perfect. Okay. So we just read about how scientists use field lines to model and study the magnetic properties of Earth. We also learned more about the geomagnetism of Earth. Next, read the message from Dr. Shapiro of the Universal Space Agency on the next slide. To student physicists, soon I will be sending some magnetic field line diagrams that scientists at the USA put together for you. Based on the model launcher tests, we will need your help analyzing these diagrams. We think examining the field lines might help us figure out whether the magnets in the model spacecraft and its launcher were misaligned during the Tuesday launch, causing the launch to be slower than expected. We look forward to reading your analysis. Okay, so he's going to give us a bunch of data. All right. So, your research question: why did the spacecraft go so much faster than expected on Wednesday? So, claim one is the magnets were misaligned on Tuesday. Claim two is much more energy was in the launcher system on Wednesday than on Tuesday. And claim three is the magnetic force was much stronger on Wednesday than on Tuesday. So these are two wild claims, or three claims. Remember, these are the three claims about the launch program that scientists would like your help evaluating. So we got these yesterday. So Dr. Shapiro mentioned in her message that the magnetic field lines diagram she will be sending might help us figure out whether the spacecraft magnet and the launcher magnet were misaligned on Tuesday, as in claim one. Let's see what misalignment might have looked like. So misalignment is not lined up correctly. Okay, this diagram shows the proper launch magnet setup on the left and the one way it could have been misaligned on the right. So here is the launcher magnet, here is the space magnet or spacecraft magnet. So as you can see, everything is perfectly lined up together. If it were to be misaligned, you can see that it's skewed. So how do field lines help predict whether two magnets will attract each other or repel each other or both? So this kind of helps us figure that out. So the magnets in the launcher and the spacecraft need to be exactly aligned for there to be the strongest repelling force between them. So they have to be perfectly snuggled next to each other. So some questions to think about. If the magnets of the launcher and the spacecraft are not aligned, how could it affect the force that makes the spacecraft move? Would the misaligned magnets still repel or possibly attract or both? How will the magnet field lines in the diagram from the launch tests help you tell whether there was a misalignment? So, okay. Okay, the section of Earth's geomagnetism article that is about magnetic field lines may help answer these questions. So you return to the article to find out how magnetic field lines may help you understand how magnets are positioned. You'll predict whether they will attract each other, repel each other, or both. As you read, you will focus on the question, how are magnetic field lines how are magnetic field line models helpful? You will reread only the second and third paragraphs of Earth's geomagnetism article, then answer the question, how are magnetic fields how are magnetic field lines, how are magnetic field line models helpful? That was a mouthful. Okay, so I have included the two paragraphs. You're just going to read them here, and then you're going to answer your question here. So what information did you find to help answer this question? And again, you're going to find them in these articles right here. So good luck and happy reading.